Alright class, today we're going to be learning about solutions. In a solution, it is a liquid, obviously with solute. It gets dissolved in a solvent that does the dissolving. Here are the jokes for the day. If you're not part of the solution, then you're part of the precipitate. And drop the base. Alright, again, the definitions you need to know for this unit. A solution is a homogeneous mixture. Homo means the same throughout. We're assuming that you stir your solute and your solvent completely. Solute is again dissolved in a solvent. The solvate's the substance being dissolved. Solvent's the liquid where the solute is dissolved. Now if you have a saturated solution, that your concentration is at a maximum, you will not be able to hold any more solute. Okay? Now that represents an equilibrium. The rate of dissolving is equal to the rate of crystallization. You'll always see them go both directions. So whenever you have the same rate, then it's in saturation. There's ways to calculate or show how strong a solution is. The four ways are, one is molarity. You'll see this one the most. It's capital M. That means the moles of solute divided by the liters of solution. Many times they'll give you grams of solute and milliliters of solution. Make sure you do your unit conversions. You could also do mass percent. That's the mass of solute divided by mass of solution. Per means out of. Percent means 100 times 100. You can also do molality. It's similar to molarity. It's lowercase m. That's your moles of solute divided by kilograms of solvent. So if you have the mass of it. And you can also do mole fraction, just comparing how many moles of your solute over your total moles of solution. And note molarity is the only concentration where the denominator contains only solvent rather than solution. You're not measuring the whole solution because let's say you add Kool-Aid and water together. You actually have a bigger solution than just the water solvent. You could also dilute solutions. A solution, when it's diluted, you're going to lower its concentration. Think about really strong Gatorade. You might want to water it down first because you don't need all the ions in it. The amount of solute remains constant before and after. So again, your moles before has to equal your moles after. If you remember your equation for molarity, it's moles over liters. So that's why the molarity times the volume initially has to equal the molarity times the volume after. So this quick situation. You have a 0.5 molarity standard sucrose sugar stock solution. How would you make 250 milliliters of 0.348 molarity? Essentially, you have to figure out how much volume to start with. 0.5 is our initial molarity times a certain volume. New molarity is 0.348, and I want 250 milliliters. You could keep it as milliliters in this, it'll keep it the same unit, milliliters afterwards. When you multiply and divide by 0.5, you get 174 milliliters. What are some of the factors that influence solubility? Obviously the nature of the solute and the solvent. Like dissolves like. If I have a covalent bond and a covalent compound for water, obviously they're going to mix better. Temperature. Solids and liquids, your solubility increases with temperature. That's because you have more kinetic energy. Kinetic energy means the particles are moving faster. There's more collisions between the solvent and solute. In a gas, however, it decreases. We'll see a graph of this later. Pressure factors. Very little effect on a solid and a liquid because remember they have set volume. However, in a gas, the solubility will increase with pressure. Think about a pressurized container like a can of soda. They have a little more pressure in the can that allows more solute to go in there. Right? Squeezes gas solute into the solvent. Here's a graph showing the solubilities of solids versus temperature. Solubility of 100 grams in water. Here's your temperatures. You notice that most of them will increase over time. Again, the reason is the kinetic energy is increasing. However, there are a few, cesium sulfide, NaCl is pretty much unaffected, where it either decreases or is no slope, no change in temperature, pressure. Here's your temperature and solubility of gases. Again, they decrease at higher temperatures. Think of soda, can of soda. it's really hot outside in the Texas summer. If you leave a can of soda in your car, it's not going to be as much carbon dioxide in there. That's the reason that you want to keep your soda cooler. Alright, that's our initial video on solubility. I'm going to be doing a new video on acids and bases, which also have to do with solubility because they depend on the strength of the acid or the base. Have a good day. Again, if you have any questions, leave a comment down below.